Hi, my name is Scott Simpson, and today we'll be talking about rate laws for elementary reactions. Typically with rate laws, you have to determine the overall rate law from empirical or from experimental evidence. And it has nothing to do with the stoichiometric coefficients. However, if the reaction is an elementary reaction, you can base it off of the stoichiometry. So what we're going to do today is we're going to discuss what is an elementary reaction, how does that reaction coordinate diagram look, and then we're going to actually get the rate laws for a handful of different elementary reactions. Okay, so the first thing we should do is define what an elementary reaction is. An elementary reaction, oops, forget the knee. Is a reaction that cannot be broken down into simpler steps. Broken down into simpler steps. Okay. And I'm going to preface this. This is a big disclaimer that you have to pay attention to. Normally, one needs to determine the rate law from experiment. Needs to determine the rate law experimentally. Another important point is generally you disregard the stoichiometry when looking at a rate law. The reaction orders do not depend on stoichiometry. So normally, again, to reiterate, big point, you need to determine the rate law experimentally, and the coefficients have no bearing, stoichiometric coefficients have no bearing on the orders with respect to that rate law. However, if the reaction is an elementary reaction, this changes a bit. If the reaction, the one that we're questioning, is an elementary reaction, its rate law is based on its molecularity. Or those coefficients. Okay, so how do we determine if something is an elementary reaction or not? A lot of times in general chemistry, the question will state these are the elementary reactions, here's the overall reaction. So you'll get a list of different reactions. Based upon the reaction coordinate diagram, let's look at two instances. So we're going to have our reaction coordinate on our x-axis, energy on our y-axis. And an example of an elementary reaction would be as follows, where we have our products, our reactants, and one transition state. So this is the energy profile, or reaction coordinate diagram of an elementary reaction. A multi-step reaction Again, we're going to have energy as our y-axis, reaction chord as our x-axis, and it might look something like this. But this is our products, reactants. We have transition state number 1, transition state number 2, and an intermediate. And actually, there are two elementary reactions that occur in this reaction. This is the first step, to that point in the red, and then the rest would be considered the second step. Okay, so let's look at some examples. So example, given the following elementary reaction. So note, it says elementary reaction. We have A plus 2B goes to C plus D. And we're going to ask the question, what is the rate law? Okay, important point. We were asked, or we were told that this was an elementary reaction. So that means we can look at the stoichiometric coefficients and we can determine this. Okay, so now we know rate is equal to K. We have, remember, it's the reactants that determine the rate. We have A and we have B. Okay, the coefficient for A is 1, so we have a 1 here, or we could just leave it as is. And then we have a 2 for B. So the rate law for this elementary reaction would be rate is equal to K, A raised to the power of 1, concentration of B raised to the power of 2. Overall, this is a third order reaction. Okay, let's look at another more chemical example, one where we actually have chemicals beyond generic things other than A and B. So again, given the following elementary reaction, we have 2 NOCl gas, decomposes into NO and Cl2 gas. We're going to ask the question, what is the rate law? Okay, again, what we need to look for, does the question ask or state if it is an elementary reaction or not? In this case, we do see elementary reaction. Once we see that, we know we're good to go with the stoichiometric coefficients. So we have rate is equal to that rate constant. So that's going to change value in units depending on the order. And we have just our reactants. So this is NOCl. And we have to raise it to the power of 2 because there's just a stoichiometric coefficient out front. Okay, so that's how you look at elementary reactions. So again, I'm going to warn you, you'll only want to consider the rate of these systems and the rate laws of these systems if it states that it is an elementary reaction. If you do not know that, or you're not going to assume that, you cannot use the molecularity or the stoichiometric coefficients to get the rate law. It's a very important point. Normally, you have to determine that experimentally. Okay? Thank you for watching. I hope you got something out of this. If there are any questions or comments, please feel free to contact me or leave a message below. Thank you.